Good evening and welcome in this use of ICT in education for online and blended learning. I am going to prepare here one video for giving this in the classroom. Creating video for my own classroom. So I have selected the course Engineering Graphics and the topic from Engineering Graphics is Orthographic Projections. I have not done a screencast for my class so far. Creating videos for my class, these are the learning objectives and cognitive levels. At the end of this course or this video, students will be able to enlist types of lines and they are used in engineering graphics. The cognitive level for this objective is 1 recall level. Explain principle of projections and elements of projection systems. Comprehension level. List methods of projections. Recall level. Define orthographic projections. Recall level. Creating video for your class. Steps. Points to be covered here. Types of lines. Theory of projections. Methods of projections and orthographic projections. Okay, so these are the types of lines. These are main types of lines which are used in engineering graphics for obtaining different projections in the various units. These types of lines are line for an outline of view, projection line, hidden line, center line, line to indicate section line. Let us see the use of these lines. Outline is used to show the projections of visible features. Projection line is used, or it is also called continuous thin type of line. It is used to show the projections of to draw the projectors, as well as it is used for extension lines, for dimension lines, for hatching lines, etc. Hidden line is used to show the projections of invisible features. Center line is used for showing the axis or centers of the circular parts of the object, circular features of the object. And line to indicate section plane is usually used to show the section lines or to show the cut section in any object. Now this slide shows the uses of these different types of lines, how it is used in the technical drawing or in the engineering drawing. So here you can see these are the outlines. Even for circular projections of the whole, we can use these continuous thick lines. Continuous thin lines are used to show the projections shown here by the red colored lines, as well as for dimension lines. These are the this is dimension line and these are the extension lines. Center type of line is used to show the axis of the center, axis of the holes, as well as center lines to show the center lines of circular parts. Next, theory of projection. The projection is nothing but this word means an image or the act of obtaining the image of an object. Technical people often refer to the image as a view. Now this is the projection system wherein we are going to learn the principle of this theory of projection. Now let us imagine that this is the screen placed at a finite distance from this light source. And in between this light source and this screen, the object is placed, the projection of which is to be obtained from this side or from this light source. As the distance between light source and screen is finite, the rays which are coming out from the light source or from the this source is of divergent type, and that's why when they meet these four corners of the object and move ahead to reach this screen, so as to get the image of this object on the screen. Image will be a dark shaded area, but the size of this image will be greater than the actual size of this front surface of the object. If we replace these elements, screen, object and light source, by plane of projection, then object remains same, and instead of light source if we replace it by observer, and when we keep the distance between observer and plane of projection infinite, then all the rays which are coming from the eyes of observer will be parallel to each other, and they will meet these four corners, and then it will move ahead to reach towards the plane. So that what will happen, the image created or generated will be of same size as that of this object or the front surface of the object. So this is called as this is called as obtaining the projection or act of obtaining the projection, and the system is called as projection system, and the elements of the projection systems are plane of projection, object and the observer. Now this slide shows the various methods of obtaining the projections. These methods are orthographic projection, isometric projection, oblique projections and perspective projections. Orthographic projection is the method of projection wherein all projectors, which we call rays from the eyes of observers, are parallel to each other and perpendicular to the plane of projection. Then this method of obtaining the projection of any object is called as orthographic projection. In isometric projections, we can obtain three-dimensional view or actual pictorial view from the given orthographic views or two-dimensional views. So this is exactly opposite to that of orthographic projections. In orthographic projections, three-dimensional view will be given, and from looking towards this three-dimensional view, we have to draw the two-dimensional views, and in case of isometric projections, from two-dimensional views we have to obtain three-dimensional view. Now these are the two methods which are used mostly in the civil fields: oblique projections and perspective projections. Now this slide shows the orthographic projections. So this is the object, this is plane of projection. An observer is towards this side and he is looking at this object so as to get the image of this front surface, blue surface of this object on the plane. So looking from this front side, the view is obtained on this plane, and that's why this view is called as front view of this object. These are the projectors. These are parallel to each other and perpendicular to the plane of projection. And that's why this method of obtaining projection is called as orthographic projections. Now when we look at this object from top, then the image or the view which is obtained on the horizontal plane is called as top view, since it has obtained from top of the object. So when we rotate horizontal plane by 90 degree, then we can get both the views, front view and top view, on a flat plane or a single plane, one over the other. So like this is the front view, and below that this is the top view. So in order to communicate all three dimensions of the object, we need at least two views. The front view will give us length and height, top view will give us length and width. So in front view and top view, length dimension is common, so other two dimensions we can get from these two views by referring to the another two dimensions of the views. Okay, thank you.